I am Shivam. Today we are going to discuss about logistic regression modeling in data science. Overview of logistic and position regression. Logistic regression, a statistical method used for binary classification, helping to predict outcomes with two possible values. Position regression. This technique is utilized for modeling count data, making it suitable for scenarios when counts are primary focus. Importance of mastery. Understanding these methods is essential for data analytic and statistical to perform effective data analysis and interpretation, informed decisions. Both techniques enables performance to make informed decisions and predictions based on reserved data set, enhancing the decision making process. Logistic regression. Understanding logistic regression. Definition. It is a statistical method used to analyze dataset where one or more independent variable predict the outcome. Outcome measurement. The outcome is logistic regression is measured using a binary variable, meaning there are no two possible outcomes. Application. This method is widely applied in various fields including credit scoring, making strategies, and healthcare analytics, where binary outcomes are common. Performing logistic regression in R. Key steps of an example. Load data and libraries. Begin your analysis by loading the dataset and any necessary libraries using read CVS and library function. Data exploration. Explore the dataset to understand its structure and identify any pre-processing needs such as handling missing your values. Pre-processed data. Prepare the data for modeling by encoding category variables and scaling numeric features as necessary. Fit logistic regression models using the GLM function to fit the logistic regression model, specifying the outcome variable and predictors. Model evaluation. Evaluate the model performance using matrices such as accuracy, precision, recall, and the confusion matrix. Performing logistic regression in Python. First, import necessary libraries. Begin by importing essential libraries such as pandas, numpy, and sklearn to handle data manipulation and modeling. Building. Load and pre-processed dataset. Load your data using pandas and perform any necessary processing such as handling missing values and encoding category variable. Initialize logistic regression model. Utilize logistic regression from sklearn liner model to create an instance of the logistic regression model. Feed the model. Feed the model on your training dataset using the feed method to learn from the data provided. Evaluate model performance. Evaluate the model performance using score method to access accuracy on the dataset. Overview of position regression. Definition. It is a statistical technique used for modeling count data where the dependent variable represent count frequencies. Use cases. Position regression is primarily applied in scenarios involving count data and contingency tables, making it ideal for analyzing accuracy for events. Difference from logistic regression. Unlike logistic regression, which predicts probabilities of binary outcome, Poisson regression predicts the logarithm of expected count of occurrence. Common fields of application. The regression model is widely utilized in fields such as epidemiology, where it can access rates of disease occurrence, and oncology for studying species counts. Performing Poisson's regression in R. First, load data in libraries. Begin by loading your dataset into R, importing necessary libraries for data manipulation and analysis. Prepare the dataset. Ensure your dataset is clean and structured appropriately with the response variable predictor and clearly defined. Feed the Poisson model. The GLM function is feed Poisson's model. Specify the response variable and predictors with family set of Poissons. Evaluate the model. Examine the model summary to assess the fit of significance of predictors. Analyze residuals for model diagnosis. Example code. Here are a sample code. These illustrate the implementation of Poisson regression in R. R's analytical capabilities. R provide extensive tool for detailed analysis and diagnosis of the Poisson model, allowing for robust statistical inference. Inductive Poisson regression in Python. First, import necessary libraries. Begin by import essential libraries, particularly state models, which is crucial for statistical modeling in Python. Load the prepare the dataset. The next load your dataset using pandas. Ensure that your data is clean and structured properly for analysis. Specify the Poisson model. Utilize the Poisson class from stats models API to define your model, allowing for the analysis for count data. Feed and interrupt the model. Feed the model to your dataset and interrupt the result. This includes examine coefficient and goodness of fit matrices. Example code. Here is the example code. Comparison of logistic regression and Poisson regression. Understanding key difference. Logistic regression, Poisson regression. First, used for binary outcomes. Used for count data. Second, outputs probability between 0 and 1. Outputs expect counts for event occurring. Third, focuses on likelihood of particular event occurring. Focuses on rate of occurrence of the event. Fourth, model interpretation through odds ratio. In Python, model interpretation through rate ratios. Fifth, assume a binomial distribution of the outcome. Assume a Bayesian distribution of outcome. Sixth, commonly used in classification problem in Python, commonly used for modeling event counts. Seventh, can handle continuous categorical predictors, typically used for rates over a fixed period. Eighth, requires large sample size for stable estimate. Poisson handles over dispersion with additional methods. Applications of regression models in healthcare. Logistic regression, Poisson regression, data-driven disease. Inclusion and key takeaways. Understanding logistics Poisson regression for informed decision making. First, importance of regression techniques. Logistic and Poisson regressions are pivotal in analyzing binary and counter data efficiently. Model selection criteria. Selecting the appropriate model hinges on the dataset characteristics and the specific research question posed. Technical mastery. Professionally, it implements these techniques in R and Python empowers analysts to extract value insights. Impact on decision making. Understanding these regression models enhance the ability to make data-driven decisions across various fields. Evaluate your statistical modeling skill. Join us to enhance your statistical modeling skill and learn how to effectively implement logistic and Poisson regression in your data project. Don't miss this opportunity to advance your expertise. Thanks for watching this video.